Okay, time to get going on our first combination circuit. Our combination circuit has 12 volts and 3 or 4 10 ohm resistors. So let's see where we end up. We've got 12 volt battery and several 10 ohm resistors. What I'm hoping that you'll see is that the top portion of this circuit is truly a series circuit. And so what I can do with that is I can combine that into one equivalent resistance by adding it together. In a series circuit, you add together your resistances. So I'm going to say that the resistance of the top branch is 20 ohms. Once I have that set aside, I can figure that I could replace both of those resistors with a single resistor of 20 ohms, and it would be the same exact thing. So the next thing I want to do is figure out my total resistance of the circuit. Now what I have are 3 branches of a parallel circuit. So what I'm going to do is use the parallel circuit formula. 1 over RT equals 1 over 20 ohms plus 1 over 10 ohms plus 1 over 10 ohms. This will get me, let me move that over just a little, that will give me a total resistance of 4 ohms once I do a little bit of math. My next step is to find my total current. Since I know my my voltage throughout the entire circuit, I'm going to find the total current of the circuit. So to do that, I'm using Ohm's law. Volts divided by resistance equals current. 12 volts divided by 4 ohms gives me 3 amps. That tells me that in the entire circuit I have 3 amps worth of current. The next question that I want to ask myself is, what exactly happens in a parallel circuit? What stays the same and what splits? And in a parallel circuit, and this is really, really a key thing to know, what happens in a parallel circuit, what happens in a series circuit. The voltage stays the same in all of the branches, and it's the current that splits. So since I know the volts are going to stay the same, that means I'm going to get a 12 volt push across those 2 resistors, and I'm just going to put my 12 volts over here because, again, I have to break it up into my series circuit there at the top, but I do have 12 volts entering that branch of the circuit. At this point, I could figure out the current in the bottom 2 branches using Ohm's law because I know the volts and I know the ohms. They're also equal, so I should get the same answer for both. Let me just do it right here. I want to find the current, so I'm going to divide the volts by the resistance. 12 volts divided by 10 ohms gives me 1.2 amps. And I also have 1.2 amps up here because they're identical. Okay, so now I know everything about those branches. Well, what about my other branch? Even though it has the same, I could put in a 20 ohm resistor here instead of having 2 10 ohm resistors. I don't really have a 20 ohm resistor. I do have 2 10 ohm resistors, and they are in series to one another. So what I need to do here is to apply the rules for series circuits to this branch because I have really a series circuit. One of the first things I want to know is, well, what's my voltage going to do? My voltage is going to split among the 2. And since I have equal resistors, one would imagine it's split to 6 volts apiece. But how would I figure that out? I don't seem to have enough information otherwise. So let's figure out what the current's going to be first. I know my current complete is 3 amps. I figured that out before. And I also know that between these 2 branches, I've used 2.4 amps. That leaves me 0.6 amps for the upper branch. Okay, with that in mind, I know in a series circuit that the current stays the same. It's just the opposite of a parallel circuit. So I'm going to put my 0.6 amps here for each of them. Now I have enough pieces to do a math equation. Right? If I want to use V equals IR and prove that it's 6 volts across each of those batteries, I'm going to take my 10 ohms and I'm going to multiply it by, I'm out of room here, my 0.6, and I'll get 6 volts. And since they're identical, I'm going to get 6 volts for each. So that's how we do the combination circuit. We're going to try another combination circuit in just a minute.